Okay, welcome to our second lesson on vectors in the plane. And in the plane is a way of saying we're talking about 2D here. So let's say I want to take two vectors in the plane and I want to add or subtract them. Well, we learned how to do that before using algebra and arithmetic, but now we want to talk about doing those things geometrically. So the first thing I want you to do is just draw two vectors over here. Let's draw this vector right here, and we'll call that guy vector V. And then let's take another guy and draw a second vector, and we'll call that vector W. And so there's vector V and vector W right up there. Now let's say I want to add those vectors. Now what I really need to do is I need to copy these, and what I'm going to do is I'm going to draw them with the same initial point. Okay? If you're going to do this on a coordinate plane, we often make that same initial point the origin. But basically, we're going to draw these with the same initial point. So what I'm going to do is something that you can't, but I think it'll be better for our purposes if I take these and just kind of drag and drop. So I want to take vector V. Again, you can just copy it, but I can drag it. And then I want to take vector W, and I want to give them the same initial point. Then what you do is you create a parallelogram by redrawing the vectors opposite one another. Think about what you did in like A2 when you talked about forces problems. And you had to do those forces problems with the law signs and law cosines. This is the same idea. So here's V, here's W, and I want to add them. So there's V, there's W. I'm going to add them, which means I need to then redraw V and redraw W and make a parallelogram, and then my resultant is that vector that comes out of the middle that you might remember from, again, A2, and this right here would be the vector of V plus W, and that's your resultant. All right, so it's the diagonal of a parallelogram. Well, there's another way to do that, too. What you can do is instead of drawing them with the same initial point, you can draw the first vector, and then make the terminal point of the first vector the initial point of the second. So take V, and I'm going to put it down here, and then take W, and I'm going to put it right here, and then just connect the initial point of the first vector to the terminal point of the second vector. So I'm going to draw that guy right there, and again, this is V plus W. Okay, and if we look here, if I compare them, this thing right here should be identical, and it is, to the other method. So two ways to add vectors geometrically. One is do tip to tip and then draw the diagonal. The other is to do what I like to call tip to tail and then just complete the triangle. Okay. This second one, I would say, and you will probably agree with me, that this is going to be your easier one. You only have to draw two things, but whatever works for you is fine. The other thing you need to know how to do is subtract vectors geometrically. So if I want to subtract vectors geometrically, again, there's two ways to do it. One is to draw the two vectors with the same initial point. Okay. So what I can do is, let's call them A and B, and we're finding A minus B. Draw a third vector whose initial point is the terminal point of B and whose terminal point is the terminal point of A. All right, what on earth does all that mean? It means this. If I want to take vector A and I want to take vector B. So we have A and we have B, and what I want to do with them is I want to subtract them. So step one is going to be to take A, take B, and give them the same initial point, and then you complete the triangle, and when you complete the triangle, you point to the first vector. So if I'm doing A minus B, A is the positive vector, it's the first vector, so I draw this thing right here, and that's vector A minus B. The other way to subtract vectors is you draw the first vector A, and then from the terminal point of A, you attach B, but you negate it, which means I'm going to flip it in the other direction. So I attach B to it, I flip it in the other direction, and then I connect from here to here, and that's A minus B again. And if we compare the two, this A minus B and that A minus B, look at that, they're almost identical. Okay. Again, which one do you think is probably easier? I would probably say that this one is easier. You just have to remember that when you draw them tip to tip like this, you are actually subtracting if you point to the first vector in that difference, okay? So there's subtracting and adding vectors geometrically. All right, now we're going to do kind of the same thing and make sure I have it all. So here are visual representations of vectors v, w, and s. Draw each vector operations resultants. So I want you to use those ideas that we did before and draw resultants for these 6 things. So what I'm going to do is I'm going to pause it, I'm going to do it behind the scenes, and then quickly go over each of them. I'd like you to also pause it, draw them yourself, and then check your work against mine, okay? All right, so hopefully you took a little bit of time to do some changes there. And what we have here are V, W, and S, and what I did is I just kind of drew over these and dragged them down. So for the first 3, if I want V plus W, I drew V. At the end of it, I drew W, and then I completed the triangle with the V plus W. V plus S, same idea. I drew V, connected S to the end, drew V plus S. V minus S, I did the triangle technique again. And remember, if you want to subtract, you put the initial points together, and then you draw an arrow pointing to the first part of the difference. So I drew V, I drew S, and then I pointed an arrow from S to V, and that's V minus S. Now these down here on the bottom, what I did for this first one, negative W minus S, is I drew negative W, which is really just W with the arrow at the other end. So I drew negative W, then I drew S, and if I'm going to do negative W minus S, I drew them tip to tip, and then pointed to the first vector. But that seems a little bit confusing, so what I also did over here is I said, well, isn't there another way to think about that? Wouldn't negative W minus S be the same as a W plus S and then negated? So I drew regular W, I drew regular S, I then connected them, but instead of going the initial point to the terminal point, I went from the terminal point to the initial point to negate that vector. W plus half an S is really just exactly what it says. Here's W, here's half an S, connect them. And then S minus 2S is really just a negative 1S, isn't it? So negative S flips the direction of the vector. Anytime you negate something, you just put the arrow on the other end. All right. 2 applications, or 1 application, and we are done. So we have 3 forces with magnitudes of 400 newtons, 280 newtons, and 350 newtons that are acting on an object at angles of negative 30, 45, and 135 degrees respectively with the positive x-axis. Find the direction and the magnitude of the resultant force. Now we can do this a bunch of different ways. I'm just going to kind of pick one here, but basically let's draw in the positive x-axis here. So there's the positive x-axis. I have a force that acts at negative 30 degrees with a magnitude of 400 newtons. So here's negative 30 degrees, and we'll call that 400 newtons, and we're going to call that A. So here's a negative 30 degrees below the x-axis, and this has a magnitude of 400 newtons. Then I need another one that's 45 degrees with 280 newtons, so that one's going to be shorter. So we'll call that B. That's got a 45-degree angle right here. And then 350 newtons and 135 degrees. So that's going to be over here, a little bit longer, but less than A. And we'll call that C. And this is 135 degrees. And I want to add these 3 together. Well, we got a couple different options. I'm going to show you geometrically, but I'm also going to do this one algebraically as kind of a reminder. So if I do this geometrically, and I want to take A, and then I want to add B, and then I want to add C, my resultant should look something like that. And we'll call that R for resultant. So geometrically, there you go, but I probably want to know like how many newtons that is, what angle that is, and that's going to take some arithmetic. So if I have 400 newtons at a negative 30-degree angle, remember that means my vector A is going to be 400 times the sine of negative, nope. So if I'm going to do this algebraically, A is going to be 400 times the cosine of negative 30, and then 400 times the sine of negative 30. And that will get me the components of my vector. So those components would be, let's see, that's going to be 400 cosine 30 is going to be 200 root 3. And then 400 sine negative 30 is going to be negative 200. And then if I want to find B, B is going to be 280 cosine 45, 280 sine 45, which is going to give me 140 root 2 and 140 root 2 here. And then for C, I am going to have, what's that last one? 350 cosine 135 and 350 sine 135, which is going to be 175 root 2, but negative, and positive 175 root 2. So I need to add all of these things together, so I'm going to pull up my calculator here and do that. So if I want to add these things together, I am going to have 200 root 3 plus 140 root 2 plus negative 175 root 2. And then I'm going to do the same thing with the y's. So the y's, I have negative 200 plus 350, nope, pardon me, negative 200 plus 140 root 2, and 175 root 2. All right, so my resultant is 296.9, 245.5, let's say. So R is 296.9, and what was the other one? 245.5. And does that make sense? I have a positive x and a positive y. Yep, positive x, positive y looks good for this. And if I want to find the direction, if I want to find that angle, what I can do from there is take the y component, divide it by the x component or horizontal component, and then take the inverse tangent of that, because inverse tangent of opposite over adjacent will get me the angle 39.6 degrees. And there is your direction and magnitude. So I have direction kind of right here, and this is also kind of the direction, but we also wanted the magnitude, so let me get that. My magnitude would be the square root of this guy squared plus, sorry for all the pen stuff, that guy squared. 385.2. So the magnitude of R is 385.2. So there's your direction and your magnitude. So we kind of have two jokes today. We have the why did the chicken cross the road, the intermediate value theorem, there's a nice calculus joke, and a non-calculus joke, because you were all waiting for it. Non-calculus joke for the day is, what kind of dessert is a cat's favorite dessert? That would be mice cream. Many correct answers to that one, but mice cream is what we're going with for today. I hope you have a wonderful rest of your day, evening, morning, middle of the night, wherever it happens to be, on the bus on your way to school. I hope you have a great day, and we will talk again soon.